We had said that completing the square will always work. And we just proved in the last video the quadratic formula by completing the square. Well, completing the square always works, and we just used it to get the quadratic formula. That means the quadratic formula will also always work. Now, we had just proved it with an x here, but it really doesn't have to be x. It could be a y, it could be a w, it could just be a triangle like I had here. So whatever your variable is, what's in front of that's your a value. Whatever is in front of your squared term is your a value. Whatever in front of your variable to the first power is your b value. Whatever doesn't have a variable is your c value when you have it all equal to 0. So if you don't have it equal to 0, you got to do that first. And then you have your quadratic formula. So let's go ahead and use the quadratic formula here. But remember, you first of all have to go ahead and set it equal to 0. So you set it equal to 0 by subtracting 33. Identify your a, b, and c. A is what's in front of your squared term. There's nothing written, so it's assumed to be just a 1 times that. B is what's in front of your term to the first power. We have x to the first power. What's in front is our negative 8. And then c is the one that has no variables, so that's negative 33. All we have to do is go up here to our quadratic formula, replace all of our a's with 1, all of our b's with negative 8, all of our c's with negative 33. Well, if we do that, we get this. Now, all we have to do is simplify. The opposite of a negative 8 is 8. Then we square our negative 8, we get 64, and then we multiply this out here after the subtraction sign, and we get, when we add that together, we get 196. Square root of 196 is a nice, neat number. All we have to do now is just continue to simplify this. It's a nice normal number, plus and minus a nice normal number. We could break it apart into an 8 plus 14 all over 2 and an 8 minus a 14 over 2. In other words, when we add these together, divide by 2, we're going to get 22 over 2, or 11. We're going to get 8 minus 14, which is negative 6 over 2, or negative 3. So we get two answers, and they're both nice rational answers, or we get two rational roots. This is the quadratic formula, and how to use the quadratic formula. So go ahead and try this one here. Set equal to 0 by subtracting your 34x and adding your 298. We get this here. Identify your a, which is 1, your b, which is negative 34, your c, which is 289. We plug that into your quadratic formula. We simplify it down. We get a 34 in front. We work out the inside. We get a nice, neat 0. Remember, the square root of 0 is 0. Adding and subtracting 0 doesn't change it. So we just get 34 over 2, which is 17. So we get 17. And in this case, that's just one rational root. This one here, solve this by completing the quadratic formula. Identify a, b, and c, plug it into your quadratic formula, simplify it down. Oh, the square root of 28. That simplifies because that's a 4 times a 7. Oh, so we get 6 plus or minus 2 root 7 all over 2. We could actually write this as a 6 over 2 plus or minus, and then our 2 root 7 over 2. Well, 6 over 2 is just 3. 2 over 2 with a root 7 is just root 7. So in other words, we get this for our answer. And really, since we have a root here, that means we're going to have 3 plus a root 7 and 3 minus a root 7. So we're going to have two answers, but it's going to have a root in it, so there'll be two irrational roots. Solving this one here, and then solve this one, and then watch the video. So that equal to 0. Identify a, b, and c. Solve it. Oh, we get a negative inside of our root. So we got to remember that complex stuff. So we are going to then get the square root of a negative 1 and the square root of 4. So that's going to be 4 plus or minus a 2i over 2. Well, we could put them each over 2, and we get 2 plus or minus I. Oh, well, that's really just two answers, 2 plus I and 2 minus I. But since we have i's, they're complex. So we're going to talk about this here in just a bit.